In the last lesson, we observed that even though we increased the counter value, the text widget in our layout did not update. This is because we did not inform our layout that something changed. In Flutter, this is done by calling the setState function, which is available inside an object of the type state, which in our case is the myHomepage_state class. This call to setState tells the Flutter framework that something has changed in this state, which causes it to rerun the build method so that the display can reflect the updated values. Earlier, since we changed the counter value without calling setState, the build method was not called again, and it appeared that nothing happened. When we dive into the documentation of setState, we observe that it's a function that takes in another function or a void callback as an argument, which is similar to the onPressed parameter of the floating action button widget. This function is used to notify the framework that the internal state of the object has changed. Generally, it is recommended that the setState method only be used to wrap the actual changes to the state, not any computation that might be associated with the change. For example, here a value used by the build function is incremented and then the change is written to the disk, but only the increment is wrapped in setState. This is exactly what we are doing as well, by only wrapping the change in the counter value inside setState, as only this statement is responsible for updating the state. It is also interesting to note that the function provided as an argument to the setState function is an anonymous function as it does not have any name. To further understand the concept of setState, let's add another floating action button that would decrease the counter value by 1 every time we tap it. Let's copy our increment counter method and create the corresponding decrement counter method. Since the floating action button parameter takes in a widget, we can provide our decrement floating action button next to the increment floating action button and put them side by side using a row widget. Let's update the icon, tooltip, and onPressed values for the newly added floating action button to act as the decrement alternatives and then hit hot reload to see the updated changes. To add space between both the floating action buttons, let's add the SizedBox widget in between them with a horizontal spacing of 12 logical pixels. The SizedBox widget is one of the most basic widgets in Flutter with a specific size which directs its child to also have that size. In our case, since we do not specify a child for the sized box, it simply adds an empty space based on the height and width provided to it. We now observe that each time we tap any of the two buttons, the counter value increases or decreases, and the call to the setState causes the build method to be called again, which then updates the widgets inside it. To make things clearer, let's remove the call to setState for the decrement counter method and hit hot reload. Now tap on the decrement button 3 times. We observe that the count does not update on the text widget. Let's add the setState callback to the decrement counter method and pay attention to the text widget when you hit hot reload. We observe that the count decreases from 5 to 2, which is exactly the number of times we tapped the decrement button without setState. This confirms that when we tapped the button without setState, the decrement method did get called and the counter value actually decreased with every tap. But since we did not call setState, the build method did not get triggered again, which led to the text widget never getting redrawn again, and hence the count on the text widget remained at 5. As soon as we added setState, the state widget picked up the latest state and triggered the build method, which caused the text widget to redraw itself and hence show the latest value of the counter variable. All of this retention of the state with hot reload happens because hot reload is stateful in nature. We learn more about this in the next lesson. To model the default app, let's only retain the increment floating action button and delete the other one.